So today we'll be studying the concept of probability, okay? Probability is literally just the likelihood of an outcome. It can also be the chance of something happening. So for example, it expresses the chances of freezing rain or getting cancer or the chances of winning the lottery. So when we talk about probability, we're talking about a fraction, which is just a probability. And you'll notice that we're always talking about the number of events by the number of total possible things that happen, i.e. the total number of outcomes. So now let's take a look at this problem here where we calculate the probability of rolling a 1 on a die of 6. So here's how we write this. We say the probability of the number 1 is equal to, well, how many times can a number 1 show up on a die? Well, you know that at the top, you know that when you look at the die, there's a number 1 on it. So there's only one possibility. Now, how many sides of there are there on the die? There are 6. So the probability is 1 in 6. Now we can leave it as a fraction or we can turn it into a decimal. Or we can write this as 1 over 6 times 100%, which gives us 17%. So that means there is a 17% probability of this happening. Now, I would prefer you to leave your probabilities as a fraction unless I tell you to turn it into a percent. Now, this last problem here, it says calculate the probability of rolling an even number on a die in 1 roll. Now, here's how I come up with this. Now, you got to think of it this way. If I'm looking for the probability of an even number rolling on the die, so the first even number is the number 2. The second number that is an even number is the number 4. The second number on a die, the third number on a die is going to be the number 6. So if you think about it, there are actually just 3 possibilities, and the total number of sides on the die is 6. So the probability is 3 and 6. Now you'll notice that the probability of 3 and 6 is not in lowest form. So we can divide both the top and the bottom, not by 2, but by 3, because the top and the bottom can both be divided by 3, which gives us a final answer of 1/2. Or you can write this as a percent like before. 1/2 times 100% gives us, well, 50%, which is what we're looking for. So our answer could be 1/2, or you could write it as 50%. Now let's quickly do a gentle reminder. So this stuff here, 1/2, really means 1 divided by 2, and then we times it by 100%. Now let's move on to our final example of the day. Oh my goodness. Now you kind of understand why we did tally charts earlier in the course, where we did histograms based on certain boundaries and tallied up their results when we did a survey. Now we're going to do the same thing, but this time we're going to do something with probability. Now, when we do this example, okay, for this example, it says a transportation study was done to see if there's a relationship between the people's ages and whether they drive to work. The results are in a tally below. So this is our tally. So imagine they went out and did a survey and they got the ages of 16 to 69, blah, 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 all these different things, right? Now, here's how we go and solve this problem. It asks us to find a probability, an empirical probability, which means we have a probability based on what our study has come up with, okay? And find that probability as a fraction. That's all we're going to do. So in order to do that, we need to know how much each tally is. So in this case, we have a total of 4 for the first range, 20 for the second range, 11 for the third range, 10, and then 15 accordingly. Now, remember that our probability was given by this. So the number of the stuff that we want divided by the total of outcomes. So the first thing that we got to do is we got to total up all of this stuff that we have right here. So in this case, we have the total amount of all of the stuff that we have right here as our numbers totaled up to be 60. Now we got to determine the probability of people that drive to work who are age 30 to 39. So we write the probability of 30 to 39 is equal to, well, if you notice, the total number of people from 30 to 39 is given by 11, is given by a total of 11, isn't it? So we're going to write this as 11 over the total outcomes, which is 60. So we can leave it as that as our final answer. Or I could ask you to tell me what the percentage is. You can do that by doing this, or 11 divided by 60 times 100% to give us the actual percentages to get. And that gives us 18%. And so now let's do the last one where we have to determine the probability that people who drive to work are under 30. So anybody who's under 30 is actually in this section here, right? Okay. Because we go up to 29, but yeah, up to 29, 16 to 29. So we have to total each group, right? So we want the probability of 16 to 29 is just going to equal, well, it's going to be 4 over 20. So we got to total these parts to get 20 plus 4 is 24. So 20 plus 4, and then we're going to divide by 60. So we're going to get 24 over 60, which simplifies to basically 2 over 5, because each of these numbers can be divided by 12 here, right? So our final result is going to be 2 over 5, or if you want to turn it right away into a percentage, you're going to write this as, well, 24 divided by 60, and we're going to times it by 100%, and you're going to get 40%. And there is your answer. So that's what you're going to be working on today. Now, I'm going to tell you that when you do, if you're not sure about doing these simplified fractions, just go and turn your final percent, your fraction that you have into a percent so that we have an idea of what each percentage is. All right. Have a good day.